Okay, today we're going to talk about understanding the unit circle, how to apply it in a more easy way to understand when the angle is going to be making the value of what we're looking at positive, negative, also different angles that are exact values that you have to solve by algebra. You can't just use the calculator because it'll plug out a decimal. Okay, so first we have the XY coordinate plane, and in terms of the unit circle, it goes from 0 degrees or 0 radians all the way to 360 degrees or 2 pi radians. The pi over 2 is 90 degrees, pi is 180 or half of the circle. When we get 3/4 down, we get 3 pi over 2, and the final part, 4 parts of the circle, will be 2 pi or 360 degrees. Now, it's important to understand where the value is going to be positive or negative. Okay, so we have a little mnemonic device, you call it, for our quadrants. Now, quadrant 1, the upper right, all values are positive, signifying with the A. Quadrant 2, only the sign is positive with the S. Quadrant 3, the tangent's positive. In quadrant 4, the cosine's positive. How I remember this? All students take calculus. Okay, so now we're going to talk about the values of exact angles. Okay, the first triangle we're going to look at is a 45, 45, 90 triangle. Okay, with this triangle, it's important, let me draw that again, looks a little ugly. There we go. It's important to remember this triangle because the angles are the same. We have 45 degrees, and 90 degrees. Okay, the two acute angles are the same. And for this to be the same, the sides have to be the same. So we have one side that's a value of 1, we'll call it, and the other side is another value of 1. To find the hypotenuse, we just have to do Pythagorean theorem. A squared plus b squared is c squared. Now to find c, we just take the square root of both sides. We get c is equal to, for this case, our a is 1 and our b is 1. So our value of our hypotenuse is root 2. Okay, so for a 45, 45, 90 triangle, we know all the values that we need for terms of sine, cosine, tangent. So let's talk about the sine, the cosine, and the tangent. The sine of 45 degrees is going to be the opposite over the adjacent. So if we look at this 45, we got opposite, which is 1, over adjacent, which is root 2. Rationalizing the denominator, we're going to multiply the top and the bottom by the square root of 2. We're going to get root 2 over 2. And that will be the value of the sine of 45 degrees. Cosine is found the same way, but we're going to look at the adjacent over the hypotenuse. And the adjacent of hypotenuse is once again 1 over root 2. Rationalizing, we get root 2 over 2. And the tangent, 45 degrees, is equal to the opposite over adjacent. Okay, so we have 1 over 1. So we know the value of the sine of 45 degrees, the cosine of 45 degrees, and the tangent of 45 degrees. And the secant, cosecant, and cotangent will be the reciprocals of the values. For example, the cosecant of 45 degrees is just a reciprocal sine 45 degrees, which is hypotenuse over opposite, or root 2 over 1. So we can find all values, all exact values of the sine of 45 degrees. So let's talk about now how to apply from degrees to radians. So if we have a value of 45 degrees and we want to find it in radians, we have this ratio that we can use. Okay, I can say that for 45 degrees over 180 degrees is equal to the same thing as radians over pi radians. It's the same ratio. That's why we can use this. Now, finding the prime factors, we have 9 times 5 is 45, 180, which is 10 times 18. This is 9 times 2. Let's see, 5 times 2. We see that the 9 can go away, the 5 can cancel, and if we move the pi over, we're going to get our value for radians. So multiplying both sides by pi, cancel that out. We're going to be left with pi over 4 radians. So wherever we see pi over 4, we know it's talking about radians. Okay, the next triangle we want to talk about is the 30 degrees, 60 degrees, 90 degrees triangle. Okay, we're going to get this by looking at an equilateral triangle. An equilateral triangle is like it sounds. It's equal on sides. Each side will give a value of 2. And the angles are also the same. 60 degrees for each. Now, if we take this triangle and we cut it in half, we're going to get a right triangle, and we're going to look at that for our exact values. So now we cut that equilateral triangle in half. This value is still 60. Now this value got cut in half. It was 60, now it's 30 degrees and a 90 degree. And the values of the sides, this was cut in half and becomes 1. This side stays the same as 2, or our hypotenuse is 2. Now from Pythagorean theorem, call this B. We'll solve for B. We know C has a value of 2. A we'll call 1. So it's 4 minus 1 is root 3. So since our B is root 3, we can substitute that into our right triangle. And from this we can find the sine of 60 degrees, the cosine of 60, sine of 30, cosine of 30. And we can also find the values of those angles in terms of radians. They're in degrees right now. We can change it to radians by the same method we used this ratio. We can change it to find it in radians. Okay. Now going back to our unit circle, what we want to talk about all along. I have my quadrants. And I'll have my little memory device. All students take calculus. Okay, now if we're given a value, let's stick with pi over 4 since we were talking about that. Reference value of pi over 4. We know from our conversion, which is just 45 degrees. So it would be lying in quadrant 1. This goes from 0 to 90. And pi over 4 from our triangle is just, we can find any angle for that. So if they ask you the tangent of pi over 4, we can get it. The sine of pi over 4, we can get it. The cosine of pi over 4, we can get it. Okay, now the point of the unit circle, I like to use it as reference angles. Like if they ask a question, find the cosine of 5 pi over 4. Well, 5 pi over 4, we can look at it in terms of reference angle to pi over 4. We know that pi can be rewritten as 4 pi over 4. So 5 pi over 4 would just be adding another pi over 4 to this 4 pi over 4. So 5 pi over 4 would actually be in the third quadrant. And with reference to pi, this value is pi over 4. And we see that the only thing positive in quadrant 3 is the tangent. So the cosine of 5 pi over 4 is equal to negative 1 over root 2. Okay, so in using the unit circle, it helps to know two triangles that we talked about, the 45, 45, 90, and the 30, 60, 90 triangle. And using the unit circle as a reference, finding out which values are positive and which values are negative. And using the quadrants to find out which is what. Okay, that is it for the unit circle lesson.